Hi, buddy. This is Mr. Folly, and welcome to Podcast 1.2. We're going to learn the difference between accuracy and precision and determine if data is accurate. We're going to write a number in both decimal and scientific notation. We're going to identify the base metric unit and the abbreviations for mass, volume, length, and temperature. We're going to know and convert between kilo, centi, milli, micro. We're going to convert split unit calculations. That would be like miles per hour or something like that. And then say that 1 milliliter equals 1 centimeter cubed. Hey, that's one thing you're going to have to know. Identify equipment that is used to correctly measure mass, volume, length, and temperature, and like we kind of did a little bit today. And let's go ahead and get started with that. Accuracy and precision. Accuracy is closeness to the target. So if I am trying to aim at, say I'm trying to aim at, let's see here, and I learned a bunch of names today. I want to aim at Ahmed. I'm going to throw a dart at Ahmed's eye. Here's Ahmed. Ahmed says, "Ooh, Mr. Feller, you're scaring me aiming for my eye." But whenever I throw it, I hit Olivia right in the ear. Throw another dart aimed at Ahmed, hit Olivia in the ear. I'm not accurate. I'm not very close to the target. I'm aiming for his pupil right here, but I'm really hitting poor Olivia over here. Accuracy is close to the target. Precision is how close the values are to another. Precision, I like to link to precision to predictability. So again, if I throw dart number 1, it hits Olivia. Throw dart number 2, it hits Olivia. Throw dart number 3, it hits Olivia. After a while, Ahmed starts saying, no, you can't throw a dart. And he's right. So that's kind of the thing there. So with a data set and kind of a normal thing, if I look at what Jill did, let's say the right answer is 4.55. Are Jill's answers accurate? They are accurate because they are on target. They're really close to the right answer. Okay. Does anyone else have an accurate answer here? Well, Josie over here is accurate. It's within that wiggle room would be the last decimal place. This one is not accurate. I call that nah. Not accurate, nah. And not accurate, nah. Predictability, looking at these two, are they close together? If you were to do another one, could you have a good guess of what it would be? Yes, so these are precise. 2.11, 8.13, what's the next one going to be? It's not precise. You can't predict it very well. 4.54 to 454.12, that's not precise. You can't predict very well what the next one's going to be. Prefixes. Okay, so the only prefixes we need to know are micro, milli, centi, and kilo. And this is millionth, thousandth, centi is hundredth, and this is 1,000 times more. So if I said, oh, you get a job making 80K a year, 80 what? 80,000. That's what the K is for kilo. Okay. And this, writing it this way, will be quite helpful for us. Okay, so you know micro is 1e6 micrometer in a meter. This would be a million micrometers in a meter, 1,000 milligrams in a gram, 100 centijoules in a joule, and 1,000 meters in a kilometer or kilometer. Metric units, mass, also called SI. So metric units are sometimes called SI units. The abbreviation for grams is little g, and the device used to measure mass is called a balance. Volume is measured in liters, which is abbreviated L, which is measured with a graduated cylinder, often. Length is in meters, that's M. That's often measured with a ruler. Temperatures in kelvins, which are Ks, or degrees Celsius, which are degrees Cs, and it's measured with a thermometer or thermometer. So saying the dog is big won't cut it. It has a mass of 90,000 grams, or a volume of 300 liters, or it's 2 meters long. That would be a 6-foot long dog. Scientific notation. Scientific notation, I think you've seen it before, but everyone forgets this stuff pretty quickly, so we'll go through it quickly. The number is between 1 and a 10, and then it's got a times 10 to the x. And I use the engineering notation, which is E. E negative something is less than 1. E positive something is more than 10. So see this right here? That's more than 10. See that? Less than 1. This guy's more than 1. He's going to have a positive e. This one's less than 1. He's going to have a negative e. Okay. So if I'm going to convert 2.55 E4 to standard notation, 2.55, I know it's going to be more than 1, so I'm going to move the decimal to the right. 1, 2, 3, 4, and it's going to be 25500. There's my answer. If I have 3.721 E negative 8, 3.721, that's E negative 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, make sure I put my decimal point there, and I can get rid of my little loopy-doo things. And it becomes 0.70372, or zeros actually. 987 million. So this will move over 1, 2, 3, 4, 5, 6, 7, 8. Now if you notice, wait, what am I doing? That's not right. So what I'm going to do is my decimal point in my mind's eye is right here. And I'm going to keep moving it until I get a number between 1 and 10. That's 98. That's 9.87. That's where I'm going to put it. So it's going to be 9.87. E, it's going to be positive because this is bigger than 1. 3, 6, 7, 8. E8. This guy right here, move it until it gets to 10. 1, 2, 3, 4, 5. 2.1 would be between that. So it's going to be 2.10 E. It's less than 1. Negative 1, 2, 3, 4, 5. Okay, that's how you do it. I hate given units and units on top. So when I hate given units, I try to cancel them. So if you remember in math class, if I have 7 halves times 3 sevenths, things that are diagonal to each other, or one on top and one on the bottom, will cancel in math class. And that's the idea that we use here. So I say, I hate given units and units on top. So if I have 9.5 years, what I want to do is I want to cancel the years. Hate you, years. So I put years on the bottom. If I put years on the bottom, they'll cancel. But I want to multiply it by 1. So in a perfect world, I know how many seconds are in a year. I don't. I know how many days are in a year, though. So I'm going to multiply by 1 because 365 days equals 1 year. Bam! Got rid of years, but I'm not in seconds yet. So I'm hating days. I hate you, days. And I'm going to go into seconds, but I don't know that, so go to hours. 1 day is 24 hours. Got rid of you, days. Ha, ha, ha. But I'm in hours. But I want seconds. I hate you, hours. I'll put you on the bottom. I'll cancel you. I got to put into something. So I need to know how many minutes are an hour. Goodbye. And now I'm in minutes, and I'm almost to what I want to be in, seconds. And I put it here to cancel it. 1 minute is 60 seconds. And then I get out my handy-dandy little calculator. Hope you get out yours too. And I have 9.5 times 365 times 24 times 60 times 60. So what I get is 299592000 seconds. Okay? And you can do that, or I would like to see it in scientific notation. And I like to see 3 digits in scientific notation. So right around that, that 5 would round up my 9. And another one that would be okay. This is full credit. Yay. So is this one, 3.00 E. 1, 2, 3, 4, 5. Wait, did I do that right? I embarrass myself and miscount on a podcast. 1, 2, 3, 4, 5, 6, 7, 8. E8 seconds. Metric conversions. Convert 3.5 million centimeters to kilometers. 3.5, not 3.5, 3,5 centimeters to kilometers. So on this, what I want to do, again, is I have to learn some of my prefixes. And I need to know 100 centimeters equals 1 meter. I need to know 1e6 micrometers equals 1 meter. And I need to know 1,000 meters equals 1 kilometer. And I need to know that, that's what I'm missing, 1,000 millimeters equals 1 meter. Okay. So I hate you, centimeters. I want to go to kilometers. So I have to go through that middle part too. Hate you, centimeters. Go through meters. 1 meter is 100 centimeters. 1 meter is 100 centimeters. Now I'm in meters, but I want kilometers. Gonna kill you, meters. I'm gonna get you. 1 kilometer is 1,000 meters. Again, you have to memorize those guys. 1 kilometer is 1,000 meters. Because really I'm multiplying by 1. Goodbye, meters. Goodbye. And then what I'm going to do on my calculator now, I cannot emphasize this enough. You will not multiply anything here. Things on the bottom, you divide. 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 So I would take 3,500,000 divided by 100. Not times. Not times. This divides 2. And this is a really common mistake a lot of people make. And if you can learn that two things like this are divided by, you will pick up an extra point on your ACT right there just by that. And you get 35 kilometers. 1.75 milligrams to micrograms. I don't like you milligrams. I'm going to go into my base unit of grams. And I know that 1,000 millis equal 1. 1,000 millis equal 1. I want micros. Don't like you grams. I'm going to put you down here to cancel you. Micrograms. And 1 gram is a million micrograms right there. So I take 1.75 divided by 1,000 because it's on the bottom times 1e6 and I get 1750 micrograms. Simpler metric conversions. I give you the hard ones first. I know I'm crazy. 18.3 kilojoules to joules. Same thing. I'm in kilojoules. I hate you, kilojoules. Oh, but the only thing I can go into is joules. Oh, wait. I know that. 1,000 joules equals 1 kilojoule. And I'm all done. I'm all done. So that'd be 18,300 joules. Convert 9,500 joules to millijoules. Hate you, joules. Like you, millijoules. 1 joule is 1,000 millijoules. So 9,500 times 1,000 is why I was hoping for scientific notation. 1, 2, 3, 4, 5, 6. 9.5 E6 millijoules. I never like to see more than 2 zeros, so that's when you choose scientific notations. I don't like to see 3 zeros. Split unit conversions, like split pea soup. Top cancels with bottom, bottom cancels with top. You got to be able to put these into a top-bottom type situation. 3.25 meters over. See, here's the top, there's the bottom, seconds. And if it just says seconds, it would be 1 second, but we don't really care. 2 kilometers per hour. So I'm trying to get to kilometers, I'm trying to get to hours. So meters to kilometers first. Hate you, meters. Love you, kilometers. 1 kilometer is 1,000 meters. 5 meters. Now I want to get my seconds into hours. So now I hate seconds. I don't put it on the bottom. I diagonal it. Seconds. 2 minutes. 60 seconds equals a minute. Now I've killed my seconds. I want to get rid of my minutes and go into hours. 1 hour, 60 minutes. So remember, these things equal each other. 1 kilometer equals 1,000 meters. 60 seconds equals a minute. 60 minutes equals an hour. 3.25 divided by 1,000 times 60 equals 11.7 kilometers per hour. Convert 950 centigrams per deciliter to kilograms per liter. Okay. 950 centigrams, per deciliter. Don't like you, centigrams. I'm going to go into grams. Whoops, except for I called it meters. Grams. 1 gram is 100 centigrams. Goodbye, centis. Get out of grams, go into kilograms. 1 kilogram is 1,000 grams. And yeah, you're going to eventually need to know these boys at that level. Goodbye, grams and kilograms. A deciliter. Hate you, deciliters. I'm going to liters, and I forgot to tell you there's 10 deciliters in a liter. I won't use that one again, I promise. So, 950. What do I do here? It's on the bottom, divide. What do I do here? It's on the bottom, divide. Divide by 1,000. What do I do here? It's on the top, multiply. Times 10. 0.095 kilogram per liter. Pretty cool. Lab equipment. Beaker. You might want to Google image some of these things and get them, or draw them, or whatever it is you're able to do. Flask. Beaker tongs. And beaker tongs have rubber grippies. Bunsen burner, wire gauze, crucible tongs is labeled for you. Clay triangle is labeled for you. Thermometer. Hey, we used that in class on Friday. Balance. Hey, we used that in class on Friday. This is a ring stand. This is a test tube clamp. That's a test tube. Is there an estimated digit on the balance? Yes. The machine does it for you. Review. Micro, milli, deci, centi, killi. I guess deci was in there for the ones you're supposed to know. So, there's a quiz coming, so you need to know what those guys are. Scientific notation makes writing numbers easier, or at least shorter. Be able to convert 1 or 2 step problems. Dude, your girlfriend's hotter than the inner white cone of a Bunsen burner, because that's the hottest part of a Bunsen burner, if you remember, on our little safety talk day. So I hope you enjoyed that. Toodles.